All right, welcome back. In this video, we are going to look at how we can use the mathematical induction principle to, prove that this information we have right here is equal to this, right? So we use the mathematical induction to prove theorems in algebra. Basically, we use them to prove properties. Okay, so mathematical induction is a technique that we use to establish the truth of an infinite sequence, of mathematical statement, typically for all natural numbers, that is the n. Okay, so we want to prove this. We have this a power m dot a power n is equal to a power m plus n. And this, according to indices, we know that this is valid. But we want to use mathematical induction principle to really show that indeed this is true. Okay, so first you have to go through some basic steps, the base case, and then we have the induction step also. So the first step that we have to go through is the induction, the base step, where we are going to prove that the statement right here is true for any, or for the smallest. This statement here is true for the smallest positive integer. Okay, so that is when we assume that n is equal to 1 to check if this statement is true. And then the second step that we have to check to see that this is true is that we have to go through the induction process. Okay, so that is when we assume that there is an arbitrary integer, positive integer, that is where we can say that m is equal to k. And that will be true if we substitute and we realize that it's having this same right here as the left hand side. Okay, and if m is equal to k for any arbitrary constant m, okay, then it will also be true for when we have k plus 1. Okay, so let's try this knowledge in here and see if it's going to hold for this particular information we are having right here. So first, let's prove for the base case. So first, let's say n is equal to 1 for any, for the smallest positive integer, smallest positive integer. So n is equal to 1 for the smallest positive integer, or m is equal to 1 for the smallest positive integer. So this can be m is equal to 1. Okay, so let's consider this statement over here. So if m is equal to 1, then we can say that a power m dot a power n is equal to a power m plus n. That is the base case. Okay, so we are assuming that m is equal to 1. So if m is equal to 1, then we're going to have a power 1 times a power n is equal to a power m plus n, right? But since a power 1 is equal to a, right, then we can say that a dot a power n is equal to a power, let's put the 1 here. Okay, so we're going to have that also here. So we're going to have a dot a power n is equal to n plus 1. Okay, so if this information is really valid, okay, so this is true, this statement is true. Okay, so once this statement is true, that is the base case. Now let's set up a hypothesis, okay, so that we assume that there is an arbitrary positive integer, okay, where we can say that where we assume that m is equal to k. Okay, so if m is equal to k, then we can see that a power m dot a power n is equal to a power m plus n. So we substitute m with k. Okay, so we're going to have a power k dot a power n is equal to a power m plus n. Okay, so we have this statement here. This statement is basically true. This will hold if k plus 1 is also working for this. Okay, so this will be true. This statement will be true. This statement will be true. If m is equal to k plus 1 holds. If m is equal to k plus 1 also holds. So we substitute k plus 1 in place of m. Okay, and then we see if that one to hold. So let's check out for that. So we're going to have a power k plus 1 times a power n is equal to a power k plus 1 plus n. Okay, so this information we have right here means that let's name this equation to be 1. Okay, so this information we have right here means that a power k plus 1 can be written as a power k times a power 1 times a power n is equal to a power k plus 1 times a power n. Okay, but we know that a power 1 is what? A, right here. So we have a power k here times a power n is equal to a power k plus 1 dot a power n. We can bring this here and send this here. So we're going to have a power k times a power n dot a is equal to a power k plus 1 dot a power n. And that is a power k indices, okay? A power k plus n dot a is going to be equal to a power k plus 1 dot a power n. So we can see clearly that this information, right? This information, a power k plus n dot a is equal to a power k plus n dot a power 1. That is a. Okay, so this we have right here. We know that a power k plus 1, a power k plus n is right here as a power k times a power n. So we do that substitution and we can see clearly that the information is valid for k plus 1. We know that when we are considering a power k times a power n times a, right? But we know that a power k times a power n is equal to a power k plus n. So we do that substitution and we know that by the laws of exponentiation or by the laws of exponents, we can combine the exponent when the bases are the same. Okay, so when we do that, we're going to have a power k plus n plus 1. That should be equal to a power k plus 1 plus n. And this is valid. Okay, so since this statement here is valid, we can say that the statement holds for k m is equal to k plus 1. This statement holds for when you have m equals to k plus 1. So we can say that by mathematical induction principle, m equals 1 and m equals k plus 1 holds for this given statement. All right, so through this process, we can conclude that a power m times a power n is equal to a power m plus n. Okay, so that is basically the process involved in mathematical induction. It's very simple. Just the truth is, abstract is the study of symbols, basic definition, the study of symbols and how you can manipulate them. The study of symbols and how you can manipulate them. So when you have mathematical induction problem, just put in your mind that you have two steps involved: the base case, the induction step where you set up your hypothesis, you consider m is equal to 1 or whatever variable you have, an arbitrary positive integer. Okay, so if m is equal to 1, then it will also hold for when m is equal to k plus 1. So you do this substitution, combine the terms, do your exponentiation laws, and then you just combine the exponent and you realize that a power k plus n plus 1 is equal to a power k plus 1 plus n. And this holds for the statement, this given statement. So we've realized that m is equal to a, m is equal to 1, and m is equal to k plus 1 holds for this given statement. Therefore, we conclude that by the mathematical induction principle, a power m times a power n is equal to a power m plus n. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, comment. I really appreciate that section. Comment and put your questions and I'll reach back to you. Thank you very much for watching. Bye-bye.